Okay, hi everyone. It's I know it's 8, but let's just wait a few more minutes so that we can get more people to join before we start. Okay, it's 3 minutes past 8. Let's just wait a little while more before we start. Okay, so that we can accommodate more people that are going to join us. Rosa, can we start now? Do we have?
I think we can start now. We have, I think like 10 people, 20 people. I think like more
Okay.
than 10 people.
Okay.
Okay.
Okay, great. Hi everyone. Welcome to week 8's machine learning paper reading club. So if you have followed us every week, so you have already done 7 weeks. So today is the 8th week. So yeah, congratulations for making thus far. So let's start our reading club today. Okay, so about women in AI, I'm sure you have seen this slide before. Basically, we are a group of, it's a non-profit think tank or do tank that work towards inclusive AI that benefits everyone, not just men, women, and it's basically for everyone. Okay, so I will just skip this because I know you've seen this. This is a recap of the list of papers that we have done for the past 7 weeks. So you have seen zero shot learning, you have seen ROC analysis, you have seen research topic sharing, learning from imbalanced data, annotation, abusive comments. So this week we are diving into items, and we'll be looking at a paper, a survey paper on the available clustering algorithms out there. Okay, and the future weeks, week 9 and week 10, we'll be doing trends, perspective, and prospects of machine learning. Okay, so let's just move on to the next one. So this one again is it's just a recap of what we have done so far, just to celebrate some a little bit of achievement here. So week one, we had our keynote speaker, and also basically a brief introduction of what this reading club is about. Then followed by zero shot learning through cross modal transfer. This was presented by Dr. Cheng from the Philippines. Week three, we did an introduction to ROC analysis. ROC, it's basically the curve. It was presented by Angela Kim from Australia. Week four, we did adversarial AI, class distance hardening, by Nay Miet Min. He's now currently a PhD student in SMU. Okay. Week five, we had learning from imbalanced data by Tu Ya Kao. Sorry if I didn't pronounce his name correctly. And week six, it's also a continuation of learning from imbalanced data by Angelica Chowdhury. Okay. Week seven, which is last week, we had abusive comments identification on Indonesian social media data using hybrid deep learning by Muhammad from UKM. He's currently a master student, UKM Malaysia. Okay, so this week, we are very privileged to have Dr. Sharifah Sakinah, who is the Associate Professor from the Department of Intelligent Computing and Analytics from UTEM, which stands for Universiti Teknikal Malaysia Melaka. So today she'll be talking about the survey of clustering algorithms. Okay, so without further ado, I will now pass the time to Dr. Sakinah. Okay, Dr. Sakinah, I will stop sharing now, yeah, and I'll hand it over to you to share your screen.
Okay, sure, Messin. Thank you very much. Okay, so is it my voice clear, Messin?
Yes, it's clear. Yeah.
All right, good. Okay, so yeah, thank you very much for the introduction regarding the machine learning application. So we can see that this is actually week 8, right, Messin? This is week 8, right?
Yes, correct. Week 8.
Okay, so we already learned many things related to machine learnings. And today we are going to learn another important topic about one of the very, what I can call it, useful method in machine learning that we call clustering method. Okay, so maybe it is good for me to share the paper first, because this is based on the paper. So I will share the paper. Give me a second. Okay, can you see my screen right now?
Yes, we can see your screen.
Okay, good. So actually, give me a second. All right, so this is the paper that I want to share with you tonight. This is quite popular paper, especially for those who are going to dive into the clustering algorithms. So in total, the number of pages is 32. So it's quite lengthy papers, but there are so many informations that you can get regarding the clustering algorithms. All right, because we know that nowadays we are living with the world full of data. So yeah, every day we contribute, okay, and got a large amount of data and information, and we store or we represent it as a data, and then this data need to be further analysis. Some of the data you can get it very easily in terms of their relationships and so on, but some data you need to do more further analysis. So one of the important method is actually based on clustering algorithm. Okay, so I will not show you the detail of this paper. We will use a kind of simple presentation to show what is in the content of the paper. So let me share my PowerPoint. Okay. right? So can you see my PowerPoint, Messin?
Yes,
And the
can. Yeah.
okay, sure. All right. So I tried to get some, some idea from the paper, and then later you can go through the paper, and also from the slide you can see what are the importance or the insightful information that sharing in the paper. Okay, so this paper is by Rui and Donald. This paper published in IEEE Translation on Neural Network. Okay, so this is about my name. So just now Messin already explained to you, so maybe I can just skip. I say also I'm from UTEM, and then I'm under the Department of Intelligent and Computing Analytics, Faculty of Information and Communication Technology. So regarding my education background, actually I'm starting as a mathematician, and then finally I'm doing my PhD in the intelligence system that focusing on fuzzy methods. Okay, so now we talk about clustering. So when we mention about clustering method, okay, actually when we talk about clustering, it's just a process of grouping similar items together. All right, so we have a kind of item or a kind of data, right, object that we can put it together and we can group them together. So clusters should be very similar to each other, but it should be different from the object of other cluster. For example, we have three cluster. So the cluster, for example, the item in cluster 1 should be similar to each other. But when we compare cluster 1 and cluster 2, so this should be different. So this is what we mean by grouping similar item together. So we can say that intra-cluster similarity between object is high and inter-cluster similarity is low. Okay, intra meaning that inside their own group. Okay, inter meaning that between the other groups. So this concept is very important. We know that in our human daily activity, we use this concept at our early childhood in distinguish between different items such as car and cat, animal and plant. So this is about clustering. So clustering is very important algorithm that can be implemented in many types of data, and then it can give us a kind of similarity among the data. Okay, to be more a little bit detailed about the clustering is about a cluster is a collection of data object similar to another within the same cluster, dissimilar to the object into another cluster. So when we deal about cluster analysis, meaning that we are finding the similarity between data according to the characteristic found in the data and grouping similar data object into a cluster. So I know that you are familiar with machine learning because we already have 7 weeks that we learn about machine learning. We know in machine learning we have several types of learning. So the one that is quite popular is unsupervised learning. So this method, clustering method, is fall under unsupervised learning, meaning that there is no predefined classes or teachers or target for this type of methods. So when we talk about application, it can be, for example, sorry. Can you see my? Okay, so it's a it's a standalone tool to get insight into the data distribution and a processing step for other algorithms. Okay, so when we talk about the application, there are so many different type of application. One of them is related to the image segmentations. So the goal here is to break up the image into meaningful or perceptually similar regions. So we can implement, you can see, it's a kind of how we can form a similar region, put them together. So they should have a kind of similarity measure. So their similarity is there. For example, we can see that the green color, we can put them in one group. For example, the water can be in one group. So this is what we call a clustering method. And then we also can use clustering in gene expression data. We know that gene expression data is a very high dimensional data. So the best method to put it into a group, specific groups, is by a clustering method. So actually clustering rich application and multidisciplinary effort. So we can use it in pattern recognition, in spatial data analysis. For example, in spatial, we are dealing with maps. In GIS, by clustering features, we detect spatial cluster and many more. We also use it in image processing, in economic science, especially in market research. We also use clustering in terms of the document classification, or we want to cluster some web blog data to discover group or similarity assess patterns. Okay, so I just want you to get some idea about this clustering method and the importance of the clustering method. So here you can see that in the application we have marketing, land use, insurance, city planning, earthquake. So for the customer segmentations, if we look at here, we can have a kind of data, and then from this data, we can use a clustering algorithm in order to segmentize the customer. Okay, so there is a process as usual. We will start with the data preparations, and then we will implement a clustering method for the putting them into a group. So we can segmentize the customer, and then we do some evaluations. Okay, next is about the image. So you can see here image segmentation applications. So from the original image, from here, you can implement a clustering algorithms, and then from here we can get the information regarding the image. For example, we can see whether there is a desert area here, there is a sea here, there is a dry land and a forest. So we can see clearly the segmentations of the image. Okay, another application just now I mentioned about insurance. So we also can implement a cluster analysis to the insurance data. Okay, and also regarding the urban planning, you can see that here we can estimate a parking capacity by looking at the result of the clustering algorithms. And here we can also learn about the urban topology by using the simple clustering algorithm such as Kmeans. And finally, we also can use a simple clustering algorithm such as Kmeans to look for the earthquake epicenter clustering. And here we can see clearly how it works, and then we can look at how the data are put together. They have a kind of similarity, and then from there we can see the epicenter of the earthquake. Okay, so now we move into a little bit detail about what are in the paper. Okay, so here we learn about the clustering procedure. Okay, so the clustering procedure, starting from we getting the data. After we get the data, we need to do a kind of feature selections or extractions. Okay, so this part is very important in order to get a very good quality data before we put into our clustering algorithms. Okay, because we know that in order to get the similarity of the item in the data, the features play an important role. So now here the features is actually related to the variables in the data. In some cases, some of the algorithm or the clustering algorithm are not suitable for the high dimensional data. So what we need to do, we need to select our features, or maybe we can do some extractions from the original features. Then we put into the related or suitable clustering algorithm. After that, we form a cluster for that particular data. But before we just can implement directly the result, we need to do some cluster validations. So here we look into the intra and the inter similarity measure, whether they have a high intra-cluster or low inter-cluster. So we need to look into that particular similarity measures. And then finally, we will do a result interpretations. For the result interpretation here, we need to work together with the subject matter expert. If we are the one who know very detail regarding the domain, is okay. So maybe we can come up with a good interpretation. But if we are not really know the detail about the physical meaning of the data, we need to work with the subject matter expert in order to give some interpretation regarding the result. So if you look at this procedure, it's quite straightforward, but in some cases, we need to go back to the previous steps. Because maybe if you look for the interpretations, the interpretation is not really what we call that practical, or maybe the interpretation is wrong. So we need to go back to, for example, go back to the cluster validation, or maybe we need to re-look into our algorithm. Maybe the algorithm is not a suitable algorithm that can deal with our data. So you can see the arrow here is not a one-way process. We need to go back sometime until looking back at the features. All right. So this is the standard clustering procedure. So after we do this kind of procedure, then we get the knowledge from the data. So remember here, this is unsupervised learning. So you just put your data, and then from this algorithm, they form a groups or a cluster that give a kind of similarity between each other. So this is what we mean by clustering procedure. Okay. So we know that we need to go through this process, and then as usual, when we're dealing with any algorithm, we need to be sure that our algorithm is good, meaning that the result is good. The interpretation that we get from the result is good. So looking at the quality of the clustering result is very important. So that's why I mentioned many times before how we look into the clustering result is based on the high intra-class similarity and low inter-class similarity. Remember that when we talk about inter-class, this is actually between class 1, class 2, class 3. Intra-class meaning that in the class itself, cluster 1 for example, cluster 2 or cluster 3. So the quality of a clustering result depend on both similarity measures used by the method and its implementations. And the quality of clustering method is also measured by its ability to discover some or all of the hidden pattern. So this is how we look at the result. So not just implement any clustering algorithm and then we get some groups, but we need to make sure that the result is good and quality group that formed by the clustering algorithm. Okay. So how we measure the quality of the clustering? By looking at the dissimilarity or similarity matrix. So normally, similarity is expressed in terms of distant functions. Okay, typically is a Euclidean distance, meaning that there is a separate quality function that measure the goodness of the cluster. So in the paper, they really give a very detailed regarding the distant functions. So the definition of the distant function are usually very different for interval scale, Boolean, categorical, ordinal data, and vector variables. So remember that you know your data. So when you're dealing with different type of data, you need to make sure that they are using suitable distant measurements. Okay, so weighted should be associated with different variable based on the application and data semantic. It is hard to define similar enough or good enough. The answer is typically highly subjective, right? So, but I just want to show you from the paper. So if you look at the paper, okay, so here is actually regarding information regarding the similarity. Okay, wait, it's a little bit small. Maybe I just use like this. Okay, so it shows the similarity and dissimilarity measure for quantitative features. So here we can see we have several type of distance measurements. For example, we have Minkowski distance, all right? So Minkowski distance here is actually this is a kind of quite similar, have a similarity with the Euclidean distance, but here the value of n can be n numbers, all right? But when we talk about Euclidean distance, we are using n equal to 2. This is a special case for Minkowski matrix. All right. So actually, if we just try to look into what are the dispersions of our data, so we can implement the right measure. So in some cases, when we have a city block distance, we are using Minkowski metric n equal to 1. So you can see the formula become tend to form a hyper rectangular cluster. So it depends. If your data have this kind of the type of data, we need to address by using the kind of right distance formula. Okay, and then we have soup distance where we have n equal to infinity. All right, and then we have Mahalanobis distance. We have Pearson correlations distance. So all of these distance have their own capabilities. And actually, if we look in terms of Pearson correlation, is widely used for measuring, analyzing gene expression data, meaning that it's quite high dimensional data. And then we have point symmetry distance, and then we have cosine similarity. So cosine similarity normally used for document clustering algorithm. And we have many more. So this is a kind of quite popular distance used in the similarity or dissimilarity measures. Okay. All right. So go back to our PowerPoint. So this is about how we look for the quality data. So the best is choose the right distant functions that we are dealing with together with the suitable with the data. Then we can see from there the calculations or how they form the group is much better compared to just using any distance. For example, normally they are using Euclidean distance most of the time. Okay, so when we talk about requirement of clustering in data, so this is a the requirement is very high actually. So first of all, it's about the scalability. And then we need to look for this clustering algorithm is ability to deal with different types of attributes. Okay, ability to handle dynamic data, discover of cluster with arbitrary shapes. So this is look into the shapes of the cluster. Minimal requirement for domain knowledge to determine input parameter. Able to deal with noise and outliers. Insensitive to other or input records. High dimensional. So nowadays we are dealing with big data. So this is one of the very important requirement that need to be considered when we use a clustering method. And incorporation of user specific constraints. So sometimes there is a constraint regarding the data. So we need to look into how we can put them together in our algorithms. And then finally the interpretability and the usability. So from here we can see that clustering research is not really end yet. So many things we can look into, especially when we deal with the high dimensional data. And then when we deal with all different types of data all together. Because when we talk about big data, we know that we have variety of data. So this is where sometimes we need to look into in terms of the clustering algorithms. Which one is the best that we can implement that suitable to form a cluster for our data. Okay, so in this paper, they mention about so many different types of algorithms, clustering algorithms. So this is some part of the algorithm. So if I just want to slightly go through the papers, you can see that, okay, here. So it mentioned about clustering algorithm is starting with A, distance and similarity, hierarchical, right? And then we have square error base. We have a kind of PDF estimations, graph theory base, okay? And then we have also combinatorial search techniques, fuzzy neural nets, kernel, sequential, and many more. So this is all what we call that algorithm that can be used to do a clustering method. All right. So I tried to make it kind of simple to put it into a group. So for example, we have a first group is partitioning approach, meaning that we construct various partitions and then we evaluate them by certain criteria. All right. For example, we try to minimizing the sum of square error. So this is the example of the clustering method, maybe Kmeans. We are familiar with Kmeans. K-mediots, Clarence, and many more. Okay, so this is what we call partitioning approach. Fuzzy means also fall under the partitioning approach, meaning that how we group them is based on the criteria, for example, minimizing the sum of square error, all right, because they are using Euclidean distance. All right. Secondly is about hierarchical approach. So this hierarchical approach is a kind of tree concept. Okay, it's create a hierarchical decompositions and the set of data or object use some criteria. So it depends. If your data related to a kind of hierarchical nature, so it's suitable to use hierarchical approach. And then we also have density-based approach. This is usually used for a kind of high-dimensional data. So the algorithm is actually based on the density measurement. So it based on the connectivity and the density functions. So for example, DB scan, optic, and then clue, and many more. Now we have so many different types of algorithms. We also have grid-based approach, right? Meaning that it's based on multiple level granularity structure. Okay, so one of the popular method is click. All right, and then we have model base. So this model base is actually a hypothesis for each of the cluster and try to find the best fit of the model to each other. So this one is normally, for example, EM or SOM. Okay, so this one is based on they have a kind of model, meaning that they contribute to they have their own hypothesis, and then from there, they, for example, looking for the probability or and so on. And then we also have frequent pattern base. Okay, and then this is actually based on the analysis of the frequent patterns. All right. And then we also have user guided or constraint based. This one is actually based on the clustering by considered user specific or application specific constraint. So that's why we see here so many different clustering algorithm, but normally the most popular one is Kmeans, right? Because it's much easier to implement and faster. Okay, so if you look at this algorithm, they have their own capabilities in tackling the high dimensional data. So this is in this paper. Hopefully later you can get the paper and then you can see. Most of you need to look into whether your data is a very high dimensional data or not. So when you deal with the high dimensional data, make sure you choose the right algorithms. Okay, for example, in this case, K-mean or fuzzy C-means, hierarchical clustering, and many more is not really good for the high dimensional data. So we need to look for other method that really good for the high dimensional data. Then the process, you can see from the procedure just now. So we no need to go back again to the previous procedure. So we just can move on to the next procedure and get the best group for our clustering algorithms. Okay, so this is about the algorithms and the complexity of the algorithms. Okay, so now we look at to get some idea about what is actually clustering is all about. We try to use a simple clustering method and a very popular one to show you the how it works lah, meaning that how the clustering method works. Okay, so if you look at here, simple clustering K-mean work with numeric data only. Okay, so how it works? First, we need to pick a number of cluster, okay, center at a random. So what they are doing in the algorithm, first they will assign every item to its nearest cluster. So normally they are using a Euclidean distance, okay, to to look into the nearest cluster center. And then they are move each cluster center to the mean of its assigned item. So then the process is repeat, okay, until it converge, meaning that change in cluster assignment less than a threshold. So they have a kind of stopping criteria how they form the groups. So this is the example. So you have the data. So for example, you just have two data, X and Y, and then we put the data in the scattered plot. So this is the data look like. So what we are doing here, we want to cluster the data into three groups. So we pick three initial cluster center. Okay, so this is for the first iteration. So K1, K2, K3 is the cluster center. Okay, so this, the purple color is the data. K1, the red dot here, the black dot here is the cluster center. Okay, and then what we are doing next is assign each point to the closest cluster center. How we do this? By using a Euclidean distance. So we look for the distance. Which distance? For example, this point, which one is the nearest? Whether near to the K1 or K2. So they are using Euclidean distance to calculate the distance from one point to the center. Then they form a group, okay, based on the closest cluster center. So this is how it works. Meaning that try to find the closest cluster center. So you can see here, they for the second iteration, they already form the three groups. But whether the group is good or not, so that's why they have a kind of similarity measures. Okay, because we know that, for example, if you look at this previous one, this K1 is still far from the others. Maybe it's quite near to this 3 point. You can see my cursor, right? But it's not really in the middle. This should be in the center because this is a center, cluster center. So we need to shift this K1 into a much better positions, so it will look into all the data and the similarity of the data intra cluster is very close. So you can see the difference between the first position and the second positions. Okay, move each cluster center to the mean of each cluster. So that's why the word here Kmeans algorithm is calculate the means of the uh, sample of data. Okay, and then you can see that it's moving from K1 to K2. K1 to the new position, K2 to the new position, K3 to the new position, which is much better in terms of the similarity measures for intra-cluster, okay, in the cluster. So this is a kind what we call just now about similarity and dissimilarity. Similarity high should be intra-cluster, right? So that's why we need to move the cluster center to the based on your mean value here. And then same with the other cluster center. Okay, so reassign point Y closest to the different new cluster center. All right. So this is how the K-means clustering works. Okay, iteration by iteration, they form a groups of 3 cluster, and then from here we can see that compared to the previous one, this is the original one, you can see that the cluster center is far from the group of the data. So the similarity between intra-cluster is not really high. So that's why we need to do the process of moving the cluster center to the nearest, near to the other value. So this one we use mean value. Okay. So this is the 3 point with animation. Okay. So you can see, right, the 3 point with the animation, and then it will move to get a better cluster center. All right. So clear on the part of K-means. So the rest of the algorithm have a kind of similarity in terms of how it works, but maybe they are using different similarity measures, they are using different stopping criteria and so on. But the big idea here is how we can put our data here into a three groups. So that is what we are doing here in clustering algorithms. So, so this is a kind of a bit detail for the clustering algorithms. So you can see here the K-means algorithm, normally using Euclidean distance, is equivalent to the minimizations of the square error criteria. Okay, so what they are using here, they try to minimum the value of the P minus Mi. So here, E here is the sum of square error for all objects in the database. Okay, so P here is the point in space corresponding to the given object, and M here is the center. So if you look at this picture, so here is the representation of the M value, and here is the representation of the P value. So what they are doing here, they want to find a very minimum value between P and M for each of the data in the groups. Okay, so then they get the summations of all data in the group. Then they can finally get the sum of square error. Right, so P minus M1 denote the distance of data object from the cluster center it belongs to. So our aim is to minimum this value in order to get a very good, cluster groups. So this is what we call how to get a good quality clustering result. So this therefore makes a cluster as compact and as separate as possible. All right. So if you look again at the visualizations here, we can see clearly that what we are doing for the objective functions here, meaning that the criteria, the error criteria here, we try to get the distance between the green box here to the center, and then for all data in this group, then we add some summations, and then we get the best, the minimum value. Okay, so we do that iteration by iteration until we get the best, and then they will stop the procedure. So as usual, we know that our aim is to get the very good intra similarity, and we want to have very high similarity in terms of the similarity of the intercluster. Intercluster meaning that between the group, the green group and the purple group. So we need to have a very far group here. So that is the aim for clustering. Almost the same. When you use fuzzy semin, also use almost the same process. When you use different type of clustering, that is the aim. But again, the measurement may be a little bit different, the similarity is different, and how it works may be a little bit different. Okay, so when we talk about K-means, because K-means is quite popular, so we know that there is a pros and cons of a K-means. For example, K-means works well when the data form compact cloud well separated from one another. Okay, so if your data is not fall under this characteristic, maybe K-mean is not suitable. All right, so you need to change to other algorithms. So method is scalable and quite efficient for large data set with complexity big O and NKT, where K is the number of cluster, N is the number of object, and T the number of iteration required. So is the complexity is not too high, That's why Kmeans is very popular. All right, can only be applied where the mean of the cluster is defined. And if there are categorical, meaning that fall under nominal and binary data, this may be not possible. Okay, so bear in mind, if your data is fall under categorical data, so K-mean is not suitable. So try to implement other method that maybe can give you a better clustering solutions. So user may not be able to select a good value for K. So this is also another problems for K-mean, because you need to give your number of K in advance, right? Because this is based on your number of K, then they form the groups. But in some cases, you don't know the number of cluster. So you need to implement other clustering method that no need to provide a number of cluster. It's automatically do the process of clustering without any information from the user. But K-mean, you need to provide the number of cluster. So the algorithm is sensitive to noise and outlier points, which can influence the mean attributes. So you can see clearly from the graphical representation just now, because it's using means. So if your data is really have a lot of outliers, okay, and then the value is far to each other, so you cannot get a good clustering or good quality clustering result. So that is the cons for the K-means algorithms. All right.
Dr. Sakina,
Yeah.
just a time check. Yeah, we
Mm-hmm.
have 8 minutes left.
Okay. All right.
Yeah, it's I know it's a very heavy topic. Yeah, so that's why
Yeah.
we need a lot of time to cover this. But just as a time check, we got 7 to 8 minutes left.
All right. Sure. Sure. No
Okay,
problem.
thanks.
Okay. So yeah, that is about the simple clustering methods and quite popular. For I think most of data scientists like to use K-means algorithm before they use other algorithm. Okay, if we maybe a kind of just slightly go back to the papers, because I really want you to at least go through the papers. Although the paper is quite lengthy, but it's very informative. There are so many informations that you can get from the paper. So just now, we look into the complexity of the clustering algorithms. Okay, and then in the paper, they really explain about each of these algorithm in detail, meaning that the pseudocode of the algorithms. So you can understand better about how the grouping, meaning that the clustering being formed by the algorithms. All right. For K-means, the difference between these two, K-mean and fuzzy C-means. So for K-means, they have a very clear distinct between cluster 1, cluster 2, cluster 3, meaning that the difference between fuzzy semin will give you more detailed information regarding the clustering. If you look at the example just now, we see, yeah, we can form 3 groups. But in some cases, if you look, I just want to show you what are the difference between K-mean and C-means. It's almost the same actually, K-mean and C-mean, fuzzy C-means. But fuzzy C-mean give you an opportunity to look into more detail regarding the groups. Okay, fuzzy C-mean will give you the degree of memberships for each of the data. Okay, what the meaning of degree of memberships? Okay, if you the result for K means just give you, okay, this green group belong to cluster 1. But for fuzzy C mean, they will give you each of the data inside here will represent by using degree of memberships belong to the group 1, group 2, group 3. So in some cases, for example, how I can put it? Okay, maybe this green box here and purple here, it's quite near to each other. We can also form like this, right? Just in case. So for fuzzy simin, they will give you the degree of membership. Whether, okay, for example, the purple one here, that one I circle here, maybe the degree of membership belong to group K1 is 0.51. Okay. But going to K3, maybe 0.49, something like that. So they give you a degree of memberships, not directly put into their group. So you can still understand that, yeah, there is a, because in some cases, we have the data that a kind of overlap. This one is very good example. But in the real world, normally most of the data is overlap to each other. So sometimes there is a insightful information regarding the overlap. So the best algorithm is by using fuzzy simin, because in fuzzy simin they give us the, if you look here, they give us the degree of memberships which belong to the group 1, group 2, group 3. So they give you each of them. For example, the total, the highest membership, meaning that we can put the highest membership belong to the same groups, that group. So sometimes we can see the membership, the highest one is just 0.5. So meaning that it's not really the highest one. Maybe this uh, kind of data have a overlap, or maybe the data is not really uh, separated very well in terms of the data. So that is about these two methods, fuzzy C means and K means, right?
Dr. Sakinah,
Yeah.
there is a question from Jason. His
Okay.
question is it suitable to use clustering for imbalanced image data set?
Yeah, sure. No problems. Because if you understand the concept of clustering, right? They are looking for the similarity. Okay, they look for the similarity. So if you have imbalanced data, I know the data is not very much, meaning that very small sample of data. But if we can come up with the similarity, the good similarity measures, so you can still see the difference between the groups, right?
Okay, but I guess with like the challenges with imbalanced data, there's always bias because it's always biased towards the majority class. So
Yeah.
I'm sure this is not specific to clustering, but it's a problem that's generic to imbalanced data set. Yeah,
Mm-hmm.
so yeah, we have to keep in mind.
Yeah, sure.
Okay, so I'm very mindful that we are almost at the top of the hour. There's
Okay.
one more question from Brian. This one, I think we really need some, I think we definitely need more than 1 minute to answer the question. His question is relating to big O notation, complexity. So he wants to understand more, what does it mean by, time and space? How do we understand this? So Brian, thank you for your question, but unfortunately today we don't have enough time to answer this. But it's a very good question. In fact, it's a question not specific to machine learning, but in computer science in general, where we talk about
Yes.
algorithms, they always talk about complexity.
Yes.
So if maybe in the future we can have a topic that focuses on complexity. Okay, so any other questions relating to clustering at this point in time? Any you can if you have any question, you can unmute yourself or you can type in the chat box. Okay, so I take it that there's no question, and I'm also mindful that it's already 9 p.m. So I just want to thank Dr. Sakinah for her time, for a very detailed walkthrough of clustering methods, and you can see from her slides that she has already put in a lot of effort to summarize the paper, which is 30 over pages, into a few slides. So therefore, we need the full hour just to go through the slides. So let me share my screen. Yeah, I just want to let you know what's coming up. Share my screen. Sharing my screen. Oops. Okay, my entire screen. Okay. Okay, so sharing my screen. Okay, so next week, potentially, I say potentially because it's not confirmed yet, we are looking at machine learning trends, perspective, and prospect. Currently, we are still trying to secure a speaker. We have the paper, but we need someone to walk us through the paper, someone who really the topic in and out so that it's able to lead us through the topic. So we are in the midst of finalizing the speakers. So at this point in time, we are not able to confirm yet, but please look out for updates in our Women in AI social media channels, i.e. LinkedIn, Facebook, and what else? Yeah, these two main channels, LinkedIn, okay, and Facebook for updates. Okay, so and also there's another upcoming event happening on 7th to 8th of December, which is in 4 days' time. It's the International AI and Data Summit. There is a co-organized by Women in AI Malaysia and as well as UITM. Okay, it's the topic, the main theme is towards more sustainable data. So if you are interested, you can register here. The QR code is here. Let me just make it full screen. So if you are interested, you can register here. It's virtual, so you can join anywhere you are. Okay. Okay. So let me see. Sorry, let me just fast forward and see what other slides. We are looking for volunteers. If you are not an expert in machine learning, that's fine. We just need volunteers to help us, in terms of developing front end, maybe web pages or portal. We need communication coordinators, video editors. So if you are not an expert in machine learning, no worries. We just need, we just need people. Okay. So let me just go back to this page here. So this is the upcoming event. Apart from next week's machine learning reading paper club, we also have this event coming up. So if you're interested, you can register here. Okay. So before we go, maybe one last call. Do you have any other questions before we end this call? You can also send us an email if you have any questions or any suggestions on what kind of paper we want you want us to present or want us to walk through. Okay, so yeah, not just question but also suggestions on future papers or future topics. Okay, our email is this one, y_apec@womenai.co. Okay. Okay, so if you do not have any further questions or do not have any further comments, then we can end here and we'll speak again next week, if not week after next. Okay, thank you. Have a nice evening. Thanks, Dr. Sakinah, for doing a deep dive for us.
Okay, sure. Brian, maybe I